In this video, we're continuing with our discussion of conceptual style, more circle questions that often appear on exams. They're quite different from the homework problems that we worked and even the problems that we covered in our lectures on Mohr circle. In our lectures on Mohr circle, we focused on how you really use a Mohr circle. In other words, you have an original area, usually and you typically know IX, IY, and IXY for that original area. And then we're looking for the principles, the Imax and Imin. We're looking for I at some angle, maybe some rotated set of axes. But again, on a typical multiple choice test, the questions are often short and easy, but you have to be able to wrap your brain around them. You have to be able to understand what the problem is saying and what it's asking for. And so these are a set of practice problems for the exam. Get your brain wired toward exam style, Mohr circle problems. So again, in a previous video, I introduced you to terminology that's used on some of these exam style Mohr circle problems, but now we're going to focus on the problems themselves. Keep in mind the problem often does not give you a Mohr circle. So most of these examples, I'm giving you a basic picture of Mohr circle. And you should sketch these really, and then use the picture to draw on what the problem gives you. And so again, the classic picture that you would draw is basically just draw a circle, draw a horizontal axis through it, which is the moment of inertia axis, and then draw a vertical axis to the left of the circle, which is your product of inertia axis. And then that circle has a center, it has a diameter or a radius, it has an Imax, and it has an Imin. So you probably should draw this generic picture on any of these problems, and you'll see that I do it. And again, these are not typically provided. You should draw it yourself and use that as a template, use that as a framework. And as you read the question, draw on here the pieces of information that you're given. And then once you figure out the pieces that you're given, then you can go from the pieces and find the answer that they're looking for. For example, a problem might give you the I average and the radius, but it might say the center is at some value. If it says the center is at some value, then you go, aha, that's I average. And so that's the center of your circle. And then it might give you the radius, or it might give you the diameter. If it gives you the radius, then that's the radius of the circle. And you have I average plus the radius gives you I max and Imin. If it gives you the diameter, then realize you have to divide that by 2 to get the radius. And so if you have the center and the radius, then that gives you I max and Imin. And this is a relatively simple problem. So this is I average and radius. And so this is I average and diameter. And again, it might say the center is at some value, but again, that's I average, and it's the center of your Mohr circle. Gives you a diameter, divide by 2, and that gives you a radius, and then you can get I max and Imin. So this style question gives you an I average or a center. It says point B is at some point, and sometimes B is called a reference point on the circle. And so it's just some point located on the circle. And so if you have a center and a radius, or it gives you a center and the coordinates of B, it might say, so in this particular example, it gives the center, which is I average, is 12. It gives you IB, the moment of inertia at B, which is 19.9. And it gives you a product of inertia at B, which in this case is 6.16. And so if the center is 12, and the moment of inertia at IB is 19.9, so it plots to the right of the center. If the product of inertia is positive, then it plots above the horizontal axis. If this would be negative, then it would plot below the horizontal axis. And so this basically gives us a center. It gives us uh, the B moment of inertia, which is the horizontal coordinate, and then it gives you the B product of inertia, which is a vertical coordinate. Once you have those guys, then that gives you enough information to draw the triangle. This is 12, and so the radius is, oh, I'm sorry, they didn't give you the radius, but if they give you the center, and they give you 19.88 and 6.16, and so then basically this vertical is 6.16. The base of this triangle, which is your Ix minus Iy divided by 2, is 19.88 minus 12, which is 7.88. And so once you have those two guys, then you can take the square root of the sum of the squares of these guys, and you get the radius is 10. Once you get the radius, then you can add that to the center to get I max, which is 22. You can subtract the radius from the center and get I min, which is 2. If it asks for the coordinates of point D, and D is maybe that corresponds to B, or point D is on the original cross section, then point D mirrors B, and so point D out here is the center minus the 7.88, which is the base of this triangle. So 12 minus 7.88 is the IU value at D, or the ID value, the moment of inertia value at D. And then at B, the product of inertia is positive 6.16. And then out here at D, it's negative 6.16. So the coordinates of D, which is 90 degrees from B on the cross section, or 180 degrees from B on Mohr circle, is the moment of inertia value is 4.12, and the product of inertia is negative 6.16. If it asks you for the theta P1 or the theta P2, and so that's the angle from B down to the Imax. And remember, 2 theta P on the circle is equal to the inverse tangent of the 6.16 divided by 7.88, and that's 38 degrees on Mohr circle. And then half of it is 19 degrees on the original cross section. If this is 38 on the Mohr circle, then it might ask you for the angle. Then this is the angle to the maximum or to the major principal axis. This angle here is to the minor principal axis, or to I min. And if this guy is 38, then this guy is 180 minus 38, which is 142. So 142 on the Mohr circle is the angle from B to the I min, and to divide that by 2, 148 divided by 2 is 74. So 74 degrees is the angle from B to the I min on the cross section, the original area. So all this problem, all it started with was a center and a point B. And from these guys, you can build this triangle. You can get the radius, you can get I max, you can get I min, you can get the angle, you get the coordinates of this point across from it. So again, these are all just exercises. We're just working your Mohr circle muscles. And again, these are typical exam style questions. And so this guy gives you an I average, which is the center of the circle, gives you a radius. It gives you an angle clockwise or counterclockwise from Imax. And it asks you to find Imax, I min, some point B. So it gives you an I average, which is 12. It gives you radius, which is 10. It gives you an angle in this case, which in this case, it's 15 degrees on the cross section, which is 30 degrees on Mohr circle. So again, read the problem carefully. So 15 degrees on the original area or cross section. So it's 30 degrees on Mohr circle. So this is the picture that you draw. I average is 12. The radius is 10. This guy's 30 degrees. And it might ask you for the coordinates of B, or it might ask you for I max and I min. To get the coordinates of B, you take 10 cosine 30, which is 8.66, and then 10 sine 30, which is 5. So the coordinates of this point here, if this is point B, is equal to I average plus 8.66, which is 12 plus 8, that should be 20.66. 12 plus 8.66 is 20.66. And then the vertical coordinate, the product of inertia at B, is 5. There. So again, you're giving pieces, and then you have to find other things. I max and I min. So once you find the radius and the I average, then the I max is 12 plus 10, which is 22, and the I min is 12 minus 10, which is 2. This is an I average, that you're given an I average, you're given a radius, you're given an angle clockwise from I min. Here, so your I average is 12, the radius is 10, you're given an angle of 15 degrees on the cross section, which is 30 degrees on Mohr circle, and this is an angle clockwise from I min. And so now you're drawing this triangle. To the left is the I min direction. And so clockwise from that is a line that goes this way, which is 30 degrees. And again, this corresponds to a B that plots in the upper left quadrant of the circle. In this previous question, this is a point B that plotted in the upper right quadrant of the circle. But now we're in the left upper quadrant of the circle. We're given, and so once we're given the radius and the angle, then 10 cosine 30 is this guy, which is Ix minus Iy over 2. And 10 sine 30, which is the 5, which is the product of inertia that corresponds to B. And so then the coordinates of B is the moment of inertia coordinate of B is 12 minus 8.66, which is 3.34. And then the product of inertia coordinate of B is 5. That gives you B. And then from that guy, you could find the angle. Of course, you were given the angle to the I min. So if the angle to the I min was 30, then the angle to the I max is 180 minus 30, which is 150 on Mohr circle, and divide that by 2, with 75 on the original cross section. And that's the angle clockwise from B to the I max orientation. Here's another example. So the problem might say, well, the moment of inertia at a particular point is 6 inches to the fourth larger or smaller than the center. The product of inertia at that point is 4 inches to the fourth. Find the radius. It gives you, you've got 2 points here that are 180 degrees apart from one another on the circle. And you said that the moment of inertia is 6 larger than the center. And so basically it's giving you this distance here, which is 6. And then it says the product of inertia at that point is 4. So it's giving you this guy's 4. So it's giving you enough information to draw this triangle, which is 6 and 4. So the radius is just the square root of 6 squared plus 4 squared, which is 7.21. And so that might be all that it's asking you for. Here's another example problem. It gives you 2 axes, P and Q. It says IP is 60 inches to the fourth. IQ is 140 inches to the fourth. And it tells you that the area is symmetric about axis P. If it tells you the axis area is symmetric about axis P, then that basically tells you that IXY is 0. And so then, which basically means that IP and IQ are principal I's. In other words, I max and I min. And so now you can come down and you can draw IP and IQ as your min and your max. And so this guy is 60, this guy's 140. And then the problem says find IXY on Mohr circle with respect to axes rotated at 35 degrees on Mohr circle, clockwise or counterclockwise from IMAX or IQ. And so again, you've drawn this picture now. So you have a circle, you've got an IP, you've got an IQ. It's asking for a product of inertia rotated 35 degrees counterclockwise from IQ. And so you draw 35 degrees counterclockwise. And of course, you know your radius now. So if this was 60 and 40, then the radius is 140 minus 60, which is 80, divided by 2, which is 40. So the radius is 40. So this guy's 40. And you get the 35 degrees. And so you can draw this little triangle, which is 40 cosine 35 is this guy. 40 sine 35 is this guy. The coordinates of this point are 100 plus 32.8, which gives you the 132.8. And then the product of inertia guy, this guy, is 40 sine 35, which is 22.9. In a separate video, I'm going to give you a few more problems like this, but these are like typical conceptual Mohr circle questions that show up on tests. And if these are confusing to you, I would strongly recommend that you go through this over and over again and look at the practice exams until you can correctly read the problem, understand what it's giving you, and understand how to start from that to get what it's asking you to calculate. And it's a different way of thinking, which is why we're practicing, okay, to get your brains working and prepared for these typical conceptual style questions for Mohr circle on your exam 4.